This is a lesson on quantum numbers. The whole deal about this entire chapter that we've been working on is light and how do atoms emit light either through chemical or through heat. Well, that light depends upon the movement of electrons. How many electrons, where are they located, all give rise to how chemicals react, and specifically, how do they give off light, which is what this chapter is all about. There are 4 quantum numbers, which will fit into a very complicated equation, which we will not do. There are 4 variables in this equation. You know, like y equals mx plus b has 2 variables, the y and the x. This one is more complicated in that it has 4. Plus, in order to calculate the values in this thing, you need to know differential calculus, which you get to second and third year college. So you don't really run into this very often. However, we can talk about the variables and how they affect the electron cloud. The first one is the principal quantum number. The principal quantum number is the major energy contributor, the major factor of the energy. Remember, the electron is a wavicle, part wave, part particle, and the energy, the waves are pure energy, electromagnetic radiation, pure energy. The principal quantum number is the thing that gives you that major oomph. It will also give you the size of the electron cloud. If you have a negative electron and a positive nucleus, they want to attract each other. The lowest energy is closest to the nucleus. This is similar to the coyote and roadrunner. The coyote pushes the rock off the edge. It has the highest potential energy on the top of the cliff. It has the lowest potential energy when it hits the ground at the bottom of the cliff. So the lowest one is the first energy level. So you number this. The first one, the first energy level is 1. Second one is 2, 3, 4, ... So the major energy determinator of the quantum numbers is the principal quantum number. It tells you the size of the electron cloud. It makes the lowest energy closest to the nucleus, and the number, the value of the variable is 1, 2, 3, 4, ... You can go all the way up to infinity. The 118 elements we have, you only need 7, 1 through 7. The next important quantum number are the subshells, sometimes called sublevels. This is the minor energy contributor. While say the anvil falls from the cliff, missing the roadrunner, that big fall is the major determining energy. If the anvil ends up on its tip or flat on the ground, that determines the minor. So that much energy as opposed to falling from the cliff top. down to the floor. So those are the major contributor, that's like the principal quantum number, and then this is like the subshell. There are, this determines the shape of the electron cloud. There are several shapes, 4 types in fact. There are 4 types, and before the quantum numbers and the variables were found out, in an experiment they noticed certain things, and they called these, identified these things as S, P, D, F. These things were how light shows up when you glow an atom. Again, another reason why we worry about the light in this chapter. These are the order in increasing energy. So the lowest energy is S, the greatest energy is F. So there are 4 types of these energy shells, S, P, D, F. Right now we only need F. The next level for the regular atoms and their way they normally appear on Earth, you only need S, P, D, F. Right now you can use them, or if there's another element discovered, you're going to have to use a G. So there's, we're on the fringe of getting a G energy level. These energy levels can have each principal quantum number can have 1 additional subshell in it. If n equals 1, that's the smallest one, it's closest to the nucleus. It's the smallest cloud, so it only has room for 1 subshell. If you have n equals 2, it's a little bit bigger, there's more space for it, so there's room for 2 subshells. If n equals 3, there's room for 3. If n equals 4, there's room for 4. If n equals 5, there's room for 5. The lowest energy level is 1s, putting them together. The next is 2s and 2p. The next would be 3s, 3p, and 3d, and so on. We're going to talk more about that in the next lesson. Orbitals. Is the next thing we're going to talk about. It is the, doesn't have anything to do with the energy. In fact, you got to put energy in to discover what the orbital is. But it is the direction of the cloud, the orientation. How is it arranged? How is it pointing? The S is spherical, or round, and it only has 1 orientation, because if you like a cue ball and you rotate it, you can't tell that you rotated it because it looks the same. So there's 1 orientation for a spherical. A P orbital is a dumbbell shape, a 3-dimensional figure 8, something like that, and it has 3 directions. In fact, it's the x-axis, the y-axis, and the z-axis. If you can tell by the pattern 1, 3, D's, we don't worry about their shape, but there are 5 of them. F, we don't have to worry about their shapes either, and there are 7 of them. 1, 3, 5, 7. but they get more and more complex as you go down. These are the two that we're really interested in with electron jumping to make light and electron combining to make complex molecules and things like that. Each orbital can have at most 2 electrons in it. Can have at most 2 electrons in it. Can have less, can have 0 or 1. But at the most, it can have 2. The other thing that you need to know about is numbers is the principal quantum number, and it is 2n squared. If n equals 1, the lowest level, then you can have 2 electrons in it. If n equals 3, 3 squared is 9 times 2 is 18. So the third level can have 18 electrons in it. If you remember biology, the first circle you put 2 E's, the next circle you can put 8 E's. 1, 2, 3, 4, 5, 6, 7, 8. Next one you can have 18. This is why. There's more space, so you have more electrons. This, by the way, is a very bad thing, and biology teachers shouldn't teach it because it's not true. The last principal quantum number, we got 4 so far. Each of these deal with the cloud itself. The principal is the major energy, it gives you the size. Subshells give you the shape. The orbitals give you the direction. And the last one is spin. Now this is really a misnomer because the electron waves can't spin. They're just sitting there. They're occupying the entire thing. Only objects can spin, but since they're wavicles, they can both be a particle and a wave at the same time. So they act like they spin, but they really don't. There are 2 spin directions, clockwise and counterclockwise. Which is which, it really doesn't matter. It's just a matter of perspective. The numbers that you can put in is plus or minus 1/2. So it can be plus 1/2 or minus 1/2. It can be a complex, major thing that is really confusing if you pay attention to and understand. Each electron, according to the Pauli exclusion principle, can have, if I could spell, it'd be dangerous. Each electron can have one, in one atom, can have one unique set of the numbers. The quantum, you can have n equals 1, you can have an S, you can have the designation of the orbitals, which we are not going to go over, and we can have a spin of plus 1/2. The next electron can have an n equals 1, it can be an S, the orbital can be the number that we didn't designate, and you cannot have a plus 1/2 that would be the same thing, be occupying the same space. It would have to be a negative 1/2. Now, you can have more than one being different. You can have all 4 being different, but you cannot have all 4 being the same. It's the analogy that I've used is like setting the house address. You can have a house number, a street, a city, Michigan. You need all 4 these to indicate where your letter is going to go. So each house has its own unique identification. You cannot have two different houses with all four being the same. You could have 104 Main Street, Lansing, Kansas. You have Main Street, Lansing, Michigan, but you'd have to have some other house number other than 104. So that is the Pauli exclusion principle. These electrons fill the atom from the lowest level to the highest in energy states according to these four quantum numbers. This ends this lesson on quantum numbers.